Hello everyone, welcome back. This is Engineer Hussein. What's happening? So, in this video, we'll be looking at vectors in 3D, where we apply the method known as Cartesian vector analysis. Before we begin, don't forget to like and subscribe to the channel. Now, one thing you should understand is that when you look at 3D vectors, you're looking at vectors acting in the x, y, and z axis. The x-axis is known as the I, the y is the j, and the z is the k. Now, with this in mind, you should understand that the plane can be drawn in this way. Sorry about that. Say we have it like that. So this is the z, this is the y, and this is the x. So this is the positive x, negative x, this is the positive z, negative z, this is the positive y, and negative y. That's how you have to understand the xyz axis. Now, you need to understand that under the 3D vectors, we have certain objectives. What are these objectives that I want us to look at? So the first objective is where we'll just learn how to express a given force or vector into Cartesian form. So we'll look at how we can understand or learn how to express a given vector into Cartesian form. Now, when you say Cartesian form, it means that we're trying to express the vector given as a Cartesian vector. But in this case, we need to do this if we're being given the coordinate directional angles. Now, when I say coordinate directional angles, I'm talking about alpha, beta, and lastly, gamma. You need to understand that alpha, beta, and gamma are these coordinate directional angles. I'll show you exactly how you're going to apply them with an example. So let us go to the example and see how best we can understand these techniques of expressing a given vector into a Cartesian form. So if you look at this question, we're being told to say express force F in the figure as a Cartesian vector. So I will change my color to red. So I want to express this given force, which is a 200 Newton force, into a Cartesian vector. I've been given these angles here. These angles have been given the coordinate directional angles I was explaining. Now you need to understand that this is food for thoughts, and you need to remember that beta will span from the y to the vector given. So in this case, what is our beta? We're saying from the y-axis to the vector given. So from the y-axis to the vector given, you're having that angle, which is what? 60 degrees. Then you need to know that alpha will span from x to the what? To the vector given. So remember that. So from x to the vector given, my x-axis is here. So from x to the vector given, and alpha is not given. So we don't know what alpha is. Let us look at gamma. Now gamma will span from the z to what? The vector given. Therefore, we could say, like we have done for these, that gamma will be from z to that, we have 45. So we're having 45 degrees to represent gamma. Now, in most cases, not even say most cases, let me say every time you have a directional angle, make sure that even other directional angles are found. So whenever you're expressing in this type of condition, you have to make sure that you find all the directional angles. Now, given two directional angles, we can find the missing angle. There is a formula which says cos squared alpha plus cos squared beta plus cos squared gamma is equal to what? 1. So we're going to use this equation to find the missing angle, which is alpha. So be mindful that every time they ask you to convert a given vector into a Cartesian vector given the directional angles, make sure that you find all the possible angles. So let us plug in and see to it that we find the value of alpha. So we know that alpha is what we're looking for, so we can make it a subject of formula. So we say cos squared alpha is equal to 1 minus cos squared beta minus cos squared gamma. So this means that you're having cos alpha squared is equal to 1 minus cos beta, of which beta is 60, squared minus cos brackets gamma, which is 45 squared. So if you compute this, cos alpha squared, 1 minus everything this other side, you end up having 0.25. Now you need to find the value of alpha, so I will root both ends, and I have cos alpha to be equal to plus or minus the root of 0.25, which is 0.5. So if I'm looking for alpha, then alpha is equal to the cos inverse of plus or minus 0.5. So for the plus sign, let's say cos inverse of 0.5. If I compute that, I'm getting 60 degrees. Then alpha being equivalent cos inverse of negative 0.5, I am getting 120 degrees. Now we're having two angles. We need to know which angle exactly is our alpha. Now by inspection, you will see and understand that the alpha we're looking for is the 60 degrees. Now why is that so? If you look at the position of your vector is in the positive f axis. So it means that if you look here, you're having your vector there. So the x component is in the positive side. Same thing with the y component. And the z is also in the positive. So that's what I mean when I say it's in the positive. That's why we'll get the one in the positive. And in the positive axis, you need to understand that your value will just be in between 0 and 90 degrees. So which means that theta is equal to what? 60 degrees. It would have been 120 if the force was not in the positive x direction. Alright, I hope it's clear. So after that, we now know all the angles that we need. So alpha is 60 degrees. So let me just erase this. I'll get my magic eraser. Increase the capacity. Then, sorry about that, destroy all of this. Alright, now that we have done that, we can simply now understand that our data has the following. Alpha is 60 degrees. So I erase that alpha. Beta is equal, if you remember from what we said, beta is from y to the fourth. So y to the fourth, that is 60 degrees as well. Then gamma is from the z to the fourth, which is 45 degrees. Now that we have all the coordinate directional angles, we can now find what we're looking for, which is the Cartesian form of the force that we have as the vector. Now, to find the Cartesian form, sorry about that, the Cartesian form we'll use the formula where we say F is equal to the magnitude of the force cos alpha in the I plus magnitude of the force cos beta in the J plus the magnitude of the force cos what? Gamma in the K. So all I have to do here is now plug. The magnitude is the 200 we have. So we say 200 cos alpha, which is 60 in the I, plus 200 cos beta, which is 60 in the J, plus 200 cos gamma, which is 45 in the what? In the K. If we use our calculators properly, we'll have 100 in the I, plus another 100 in the J, plus 141, if you say 200 cos 45, give you 141.4213562 in the K. So it means that our 200 force will now be 100 in the I plus 100 in the J plus 141.42 in the K. I'm rounding off my values to decimal places. So that is basically what I will have as my Cartesian vector of the 200 Newton force given. So remember, every time they ask you to convert or express a given vector into a Cartesian vector, the first thing you're supposed to do is to find all the directional angles that are needed to use to find that particular expression. Then after you find all the coordinate directional angles, simply just use this formula here, then apply what you have by plugging in and then compute, and you will have your given vector into a Cartesian vector. Alright, thanks for watching. If you have questions, you can reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and remember to strategize before becoming a statistic, and let's try and push for that A+.